Hello. I'll take the table, actually. Yes, I would not do a magic trick, but I do always carry my card. So if you want to see a magic trick, I'll show you outside. And it's an AR trick enabled with these cards. However, as all magicians, we have a secret. So I cannot teach you how I did the trick, but I will teach you the principles that now can enable you using your smartphone. Either, I got both. So those who like Android, using one of the Pixel phones, or I have the S8 or the iPhone that supports ARKit. So with that said, if I can get an idea, this is going to be a little technical talk. How many people here are developers? Okay. And how many people would be designers? Say, okay, great. So I have a bit of both. And for others, it's not going to be super technical because I only have 20 minutes. And I'll explain everything so you have a good idea of the current state of affairs for mobile development. So AR, a lot of talk, a lot of companies here, including John and others, they built head-mounted displays or heads-up display. I don't know what's the difference between the two. But in the last few years, I've been doing mobile development. And I'm putting my money on mobile AR, at least for the next, I would say, 5 to 10 years. Mainly because I see the growth. I am originally from India, and I was recently there. And I see most of the people have Android phones, and they want interesting applications, games, like Pokemon Go. And it's been since 2016. We haven't delivered another breakthrough experience in AR. And right now is the best time because Google and Apple, they are pushing the framework. They are creating a toolkit with APIs so that you guys can deliver awesome AR games. And they are also looking to promote your application. So they have on iPhone, I'll show you, there's a Play Store, has a special section for AR apps. And last year, they were looking for developers to submit it to Apple so that they could promote you guys. So that's the advantage of being on mobile. We have the reach. This is a slide I got from DigiCapital. This is kind of like they're predicting the growth. And it's interesting. They have divided Android. So that is ARCore. That's what Google called its AR framework. Into, of course, as we all know, Android is Google Play and non-Google Play, which is mostly in China. So right now, iOS ARKit framework is on the rise. Many reasons, mostly because they came up with a better solution, and they also have a lot of apps already. Google's just came out of beta. It's still in developer preview, and it's limited by the number of devices it supports right now. But there are many workarounds where you can run, especially Android applications on older devices, and there are other frameworks and technologies as well. So my focus will be on these two, and the slide kind of got cluttered, but this is the most important slide, and basically it's important to understand the concepts. So both the framework, ARKit and the ARCore, they have encapsulated a lot of the hard work. Like if you read the computer vision and augmented reality papers, they talk about a lot of these terms, including SLAM, visual odometry. Google's framework, they call it COM. It's something similar. So the first problem what these frameworks solve is tracking. So when you look through your device, it's kind of like the first-person view. If I draw a 3D scene here, and I'm looking through the phone, I need to track both the object in space and also the motion of this camera, the phone. So for that, in the past, we used many techniques. Most common was visual odometry. Now the framework has encapsulated that. It does the low-level work of detecting data from the IMU sensor, from the camera using computer vision, and it keeps track of the plane and of the anchor points that it draws, registering the horizontal plane. That's the first thing, tracking. Next one is scene understanding. And again, this is also simultaneous localization and mapping of the scene in real time, dynamically, as you're moving the camera around, it's keeping track of what is being rendered, and so that when you change your perspective, 6 degrees of freedom, it stays there, and it doesn't move around, shift around. So it stays on a horizontal plane, kind of maintain the real-world physics. Very important. Lastly, all the apps need to be rendered mostly in 3D, but of course, you can also put 2D content, and it needs to be delivered in 60 frames per second, and lighting is a big part of it, because Apple describes it, they call it a reality illusion, and I loved it, being a magician, because they explained it. So when you see a 3D model in space, and depending on the lighting here, like on this stage, it's brightly lit, the object need to have the same lighting. And how they do it is using the camera, computer vision, this is the framework, it detects the light that is being reflected from this plane, or like using the front camera, if I do face tracking, it detects the light from my face, and then it senses that light and it renders the model in the same light luminosity. Or that's the object lighting, and then it also detects ambient lighting around the space. So lighting is big, and there are many ways to render the 3D content. I'll go more deep into this, but just quickly for iOS, they have a low-level API to create 3D graphics called Metal, and then there is a higher-level abstraction, Scene Kit, and then Sprite Kit for 2D content if you want to render. For Android, they don't really have a particular like a graphics engine. You use OpenGL programming APIs, and they have something called Surface View, which is just a view which is where you can add your own 3D models, but using code. So it would be OpenGL or using game engines. Sorry, the slide cut off, but at the bottom, it's very important to know these two because they make life a lot easier, so you don't have to write low-level OpenGL shader code, which is JMonkey and libGDX. These are two high-level game engine frameworks in Java. There are two more points under that where everybody's talking about Unity. So I come more from a programming background, Java especially, and JavaScript. So I kind of tend to stick to my strengths. I have played with Unity, but I prefer writing code. So the other two ways is Unity or Unreal Engine for rendering 3D, and then also now using web technology, using JavaScript, you can do cross-platform deployment. All right. So enough said. I'll show you on iOS 11. You need phones that support the M9 motion sensor, basically. So which is like iPhone 7 and above, I believe, and of course running iOS 11. And then it's free. And when you create your Xcode project, they have a special like augmented reality template that you get started with, and it does the boilerplate code, and then the framework has classes that you need to be aware of. So the important one is the AR session, because you have to start this session, and then you have to pass it the world configuration. Now there are many APIs, and there are a lot of sample applications that explain all of these in detail. And I'll mention in the end, I'm also writing a book on this topic. So if you want to learn more, that'll be coming out later this year. And what it also does, it does plane detection. So now I want to do a little demo here to make sense of all of this. You can see my screen. Let's start with the basic app. Now, here, the fundamental problem they were trying to resolve is detecting plane. So at the bottom, we have the Scene Kit, kind of like the real-time inspector. So it's showing how many frames per second, what color you're seeing right now. It's gray. It's waiting for drawable. It's showing the state real time. It's useful for debugging. So right now, all this is doing, actually there is too much light here. A textured surface is even better. So as you can see, it's drawing the anchor points. So I'm losing track of it. Maybe this will be better. Yeah, this carpet is better. So as you can see, it's drawing the surface. Now, This is not that interesting, but this is the hello world, believe it or not, and it's quite an achievement that the framework does it for you. Now here is where we have the plane being detected. So the framework can only detect horizontal surface right now. So carpet, this thing, table. Unfortunately, if I go against the wall, it can't detect vertical. So if you make a game, the character won't know when it can go through the wall. It doesn't know there's a vertical plane. So it does know a horizontal surface, a plane, so it says surface detected. Now all I can do simply is I can drop a 3D model. So I can put let's say a chair here, and as you can see, there is a chair, and I have simple interactions here just to kind of move it around in XYZ axis. And the chair has shadows. If you look at the details, see its legs, it has shadows, and the lighting is also reflecting the lighting of this room. So all of this is quite simple. It's just a few lines of code, one class, and there are many samples to get started. And I can of course drop other things. So I can put I can put on this. I have to get the surface, and I'll put a cup here. So I can put a cup, and if I move around my camera, you'll see it maintains the geometry. It's on the anchor points on this plane, so I can look through it from different places, and it stays there. So this is quite an achievement compared to the rudimentary, the marker-based AR, like in Pokemon Go, where the Pokemon, they could show up anywhere, hanging out in space, and not on a level surface. I'll also quickly demo, I think this is a face tracking using the 3D depth camera in the front, and it generates a point cloud reflecting. It has an infrared sensor that reflects light all around me in my face, and I can move my face, and it creates a 3D mesh, and you can put different kind of textures and all kind of fancy stuff. It can detect eyes, AR, and also, of course, you can put a little droid in your face. So it's pretty cool. Interesting thing I'll point out right now is a lot of times it will lose the tracking. So on the top right side, you'll see there's a little refresh button, and it'll start a new session. So it's a good UX practice to allow the user to reload, refresh the scene, because it will go wrong. Same here. They have put a little X, so it cleans up everything. All right. So I will continue. And like I said, rendering is one of the hardest things, and Apple has done a good job. A few years ago, they created these frameworks mostly for game developers, so that you can write games in iOS without having to use game engines. And you can get the performance benefit. Also, you can keep the size of the application smaller. And yesterday, somebody was talking about, like, if you want to develop mobile AR, we need to have access to the low-level APIs, the underlying stuff. So Unity, those are closed engines in iOS land. Whatever Apple gives you access to, at least you have access to those low-level APIs. Android, it's even more open source. So you can see the whole AR code. It's on GitHub. So this is a simple hello ARKit app. You create your session object first. You pass in the world configuration. And this is the renderer function, inside which I draw a plane, a scene kit plane, and I pass it in a plane node object. And then I add that node in the end. I also calculate angle because I need to keep it horizontal because of my scene is rendered. And I reduce the opacity a little bit so we can see the plane, and then I put the object on top of it. So this is more of the same code. It's handling some other edge cases. In this case, estimating, because it needs to recenter the 0, 0, 0, the coordinates in the center. So that's what you handle here. And this is kind of what we saw. So first, you detect the surface. And once you detect, it shows you a bounding box, the yellow box. And then you can drop anything there. Like we saw Charlie's book yesterday. You can drop a 3D model of yourself. You can put an animated one, and then you can add more interaction to it as people click on it. And since it's a mobile phone, you have way more information through GPS, through all the sensors of the phone, and also you can speak to it. So Apple also introduced ARKit, and I have given a lot of talks last year on voice user interface, because that's also one of my passion. I made a lot of demos using that, and iOS. So when you're working in the framework, you can use other APIs or other frameworks, ARKit too, if you want to say something with Siri and then interact with it. So you can have a voice interface to move some object, to do some kind of interaction. All right, so there are many practices for user interaction in augmented reality. Right now, Apple recommends keeping things simple because users are learning this new modality, like new way to interact with 3D content using your mobile phone. So they say allow people to interact with familiar gestures. So like we were saying, on mobile phone, we're familiar with the touch gestures, single touch, double touch, swipe, those kind of things. So since you have access to UI kit and all the touch gestures, you can and all the UI elements, you can use the same pattern, design patterns, and keep the interactions simple, especially because if you worked with Unity, it took me so long to understand how to move things around in 3D space, rotation and translation of objects. And the same thing user has to do when they are moving the objects around. And how do you introduce that when you can only swipe left, right, up, and down? How do you tell them to rotate the object? So that's why they are recommending keeping the gestures simple and familiar right now. And then, of course, there are many other things like hit testing. So on this form factor, we have a small screen. We can only show so much. So a tablet is a better form factor for augmented reality, is more immersive. So when you tap around the object, don't make the user click the point and touch the object just at that, like, you need to provide a touch target, larger touch target. Now, let's move on to Android. So Android, it's similar, but I would say a little bit, it's still in developer preview version, so it has less features, and the documentation is also a bit lacking, but Google is working on it. I see a lot of activity on GitHub, and there's open source community, so people have created a library which can port the ARCore to older versions of Android or different Android devices as well. So right now, you need these devices, and you also need to install a APK file that Google can update easily. So if everything was in your app, the framework, then users would have to update it constantly. So this is side-loaded ARCore preview APK, which does a lot of the tracking, lighting, a lot of the underlying work, and then your application handles hooks to those APIs. So you need to have that app installed, and then this is the Hello AR application that comes when you download ARCore, and basically you kind of need to know OpenGL programming language, ES, at least for this example. And I've seen another demo, and I worked on it using libgdx, which makes life a little easier. And there are essentially two packages and classes within them. So there is the com.google.arcore package, which is basically all that you need to know and all the features. So anchor, the camera access, because you're tracking everything using the camera, the configuration, the frame, the hit result, all of these classes, and of course they have their own methods and fields that you need to use, and there's documentation, but really you need to kind of dig into the code and understand, because the documentation is a bit lacking. So people are writing blog posts about it. So I won't go into the details of these, but these are the classes that you need to, you can take photos of that. It's also in the Google Developer Portal. And there's more enumerations, and then there are exception classes to handle exceptions, because we don't want to just crash the app. So current challenges. With these frameworks, there are still challenges. There's problems with lighting, problems with user interaction. There is no official human interface guideline for augmented reality yet. So everybody is trying to create their own gestures, their own interactions. Occlusion is a big problem. So how do you? So I can put. Let's see. Have you seen the YouTube video, which is showing the dark side of augmented reality? And basically, you go to a grocery store and you see products, and on top of it, it augments information. But it occludes. You can't see the cereal box behind. You can't see information because you've overlaid text on top of it. So how do you know what's behind it and not to obstruct the physical information and put your digital information alongside it? So there are many problems understanding 3D scene. Right now, they just provide horizontal scene for both the frameworks, and we would, like to have, no, this is a table, and this is a sign, and this is a projector, and this is a person. So a lot of that information is missing. And there is another way to do it using web technology. So Google has created JavaScript libraries using Three.js, which is a 3D JavaScript library for creating AR experiences both on Android and iPhone. I just wanted to mention that slide because there's a huge number of JavaScript developers out there. And also, I want to talk about design, because this is, after you learn 3D programming, the other challenge is, okay, now how do I create these 3D models? Or how do I code the 3D scenes? So creating 3D model, there are many tools. If you want to go the open source way, there's Blender, of course, which can let you create model, animate the model, and then you can import it into iOS, Xcode, or on Android. Android is a little tricky. iOS has a nice workflow, so it gives you a blend file, and then you can convert that, export it as a .dae file, which can be, there is many libraries. There's also a few lines of code, which lets you convert that into a SCN, which is a scene kit file, and then you can render the scene kit file in your iOS application. So it's a few steps involved. So we need better tooling right now. Ideally, what I would love is expanding the interface builder in Xcode and let you create 3D models right within the Xcode environment. I think if Apple can do that, or a third-party company in open source can create that, we don't need to open all these different tools or learn Unity just to create 3D environments. So I feel, hopefully, if somebody from Apple is listening, maybe you'll create something that'll be much more easier for iOS developers. Android, it's more hardcore. You have to, there's this library, this is basically libjdx Java library. It's a game engine for graphics programming. And inside that, you have this class obj loader. And within this class, you can load an .obj file that you can render on the fly in your Android application. So it's a bit convoluted. But companies are working on it. Amazon created an open source, or not open source, but a free-to-use software called Sumerian. And it is basically for 3D programmers and artists to create 3D scenes and models for VR, AR purpose. So it's free to use. They recently launched it, and I would highly encourage to check this out, because the more tools, the easier they are to use, the better for us. And of course, in the last talk, we saw Google Poly. So a lot of people are contributing to this. They're putting their 3D models out there. You can download them. This is free, open source, and you can just use those. So what about the future of AR? Because really, when I started, I wanted to explain that, let's go beyond the gimmicky, the marker-based AR experiences, because we are here at the conference, and we're at the cutting edge. So all of you guys, where we are in the middle of this cutting edge revolution that's happening. And I believe it can't happen by itself, because augmented reality, like we have heard talks yesterday, it is great, but it needs innovation in other domains. So I feel advancement in computer vision, so being able to use OpenCV computer vision library, which allows you to detect this is a table, this is a person, it gives you the classification and the label, and then you can augment your environment. So combining that with natural language processing, such as voice or text, like Google Lens, if I can read the text, it translates it for me, or those notes, and it augments maybe a video on top of that note when I point my camera. So leveraging other domains, natural language processing, vision, audio, so voice interaction, and of course machine learning would make the augmented reality experiences the next level immersive that we are all trying to make. So these are the 3 domains I feel like they all probably go hand in hand with each other. And resources, if you want to learn more, designer, developer resources. I'm writing a book on it. If you have any questions, concerns, please email me. I'll be hanging out here. I'll also love to show you a magic trick. And with that, thank you very much.
Did you want to wear the hat?
Yes, I just I was supposed to put this on when I was talking iOS, and I had an Android hat, but